Hello, my name is Diana Turmahan, and I am the undergraduate research assistant at Institute of Smart Systems and Artificial Intelligence. This is the first part of tutorial aimed to introduce to speech command recognition. First, let us start by defining the difference between speech recognition and speech command recognition. Speech recognition is a technology that converts continuously spoken language into its corresponding textual representation. It can handle diverse accents, languages, and speaking styles, making it adaptable to a wide range of linguistic variations. However, the effectiveness of SR relies heavily on large-scale datasets for training the model. Furthermore, its implementation demands powerful computational resources. In contrast, speech command recognition is a subset of speech recognition that focuses on spotting a set of keywords. SCR offers several notable advantages over traditional SR approaches. Firstly, SCR demonstrates efficient processing capabilities exhibiting quick response times. Additionally, SCR entails reduced complexity compared to general-purpose SR systems as it is designed to specifically target a limited set of keywords. As a result, SCR possesses a small memory footprint, making it suitable for resource-constrained devices. There are many areas where this technology can be applied. For example, automotive industry, healthcare, home automation, robotics and automation, gaming and entertainment. One of the most popular applications is home automation system, like smart home. This technology enables you to control your home devices using your voice, making your daily routines much more convenient. The second is voice activations of voice assistants. Voice assistants like Apple's Siri use techniques such as constant listening and the keyword spotting using SCR to detect when the user wakes them up by uttering trigger word from specific vocabulary like "Hey Siri" or "Hey Assistant" and so on. Speech command detection pipeline is as follows. The first step is data collection. Data collection is a critical process in SCR system development, and there are several approaches to gathering the necessary data. The first is open source datasets that are publicly accessible data for research and development purposes. The second is crowdsourced data collection that involves obtaining data from large group of individuals. Additionally, synthetic data generation techniques can be also employed to create artificial datasets that mimic real-world scenarios, expanding the available data for training. The second step is data cleansing. It is the essential step in data pre-processing phase where incomplete, incorrect, quiet, silent, and noisy recordings are manually checked and removed from the dataset. This process helps ensure that remaining data is of high quality, improving the accuracy and reliability of the model trained on clean dataset. The next step is model development. During model development, there are two approaches: developing a neural network-based model or employing classic machine learning algorithm. Neural network-based models, such as deep learning models that can learn complex patterns from data. On the other hand, classic machine learning algorithms such as decision tree or support vector machines rely on statistical and mathematical principles to build models based on explicit features. After we came to model training, validation, and testing. During model development, the model is trained and tuned on a training and validation set. Respectively, the best performing model is then evaluated on independent test set to assess its performance on unseen data. And the last step is model deployment. After obtaining the best performing model, the weights of the model are saved and the model is deployed on edge device such as smartphone or IoT devices. However, there are challenges when constructing a lightweight, robust speech recognition model that can be faced. One of the major challenges in speech recognition is data collection. Collecting and cleansing data is time-consuming and requires human labor. Secondly, speaking variability and noise are also significant challenges in speech command recognition. Speakers may have different accents, pronunciations, and speaking styles that can impact the accuracy of the model. Additionally, ambient noise can interfere with the recognition process, making it difficult for the model to distinguish between speech and the noise. Finally, ethical considerations are also important when it comes to speech recognition technology. There are concerns around privacy, consent, and potential misuse of data collected. The development of SCR systems requires the use of diverse and representative speech command datasets for model training and evaluation. Google Speech Command Dataset is open-source datasets for speech command recognition that contains wave format files with maximum 1 second duration at 16 kHz sampling rate. It's available in two versions, version 1 and version 2. Version 1 contains over 64,000 recordings collected from 1881 speakers of distinct keywords, while version 2 expands the dataset to over 100,000 recordings from 2,618 speakers and 35 keywords, also introducing more variations in background noise. This diverse sample of human speech commands has made the Google Speech Command Dataset a frequently used benchmark for evaluating SCR performance. The advancement of SCR in languages other than English has been hindered by lack of comprehensive datasets. However, due to increasing need for SCR systems, several of them have emerged in various languages. For example, Vietnamese speech command dataset consisting of 15 commands reported a recognition accuracy of 98.2% using recurrent neural networks. The dataset consists of 4,395 utterances collected from 293 speakers using speech collection application. The second one is Italian Forestry Speech Command Recognition, a speech command recognition system specifically designed for forestry domain, employs a convolutional neural network model and operates on dataset comprising 33,627 utterances collected through WhatsApp from approximately 500 speakers, achieving an impressive accuracy of 93.9%. And the last one is Indonesian Speech Command Recognition System. Powered by a convolutional neural network model, utilizes a dataset of approximately 10,521 utterances collected through microphones. With 6 keywords and recordings from 18 speakers, this advanced technology achieves an exceptional accuracy of 99.4%. And now, let us introduce speech command recognition for Kazakh language. Our pipeline is as follows. Firstly, to eliminate time-consuming and labor-intensive dataset collection step, we created a dataset by generating synthetic speech commands using text-to-speech model and by extracting speech commands from general-purpose speech corpus using speech recognition model. Secondly, to show the efficiency of our method, we collected a real-world speech command dataset for testing purposes. The dataset that we call Kazakh Speech Command Dataset was collected using Telegram bot from 119 subjects. And finally, we trained a lightweight model using our dataset and deployed it on edge device with limited computational capacity. And here you can visualize our speech command recognition pipeline. Initially, we generated training and validation data using TTS model and scrapping a comprehensive open-source speech corpus for Kazakh language, which is called Kazakh Speech Corpus 2, using VOS speech recognition model. To expand the dataset, we applied various segmentations to the raw audio signals. Subsequently, to demonstrate the effectiveness of our approach, we collected real-world data via Telegram bot for testing purposes. Then we trained and evaluated keyword MLP model on our dataset. Ultimately, the model were deployed on a Raspberry Pi with limited computational capacity, thereby illustrating potential applicability in our industrial settings. In the next tutorials, we will discuss every step in detail. Thank you for your attention.